right, let's do another one. Okay, on this one, my exponential pieces are already isolated. There's nothing down with them. There's just stuff up in the treehouse. I can't rewrite a 3 and a 7 as like bases. There's no way to do that. So I'm just going to go straight to writing them as logs. It doesn't matter which log you use on this one. I don't have an E and I don't have a 10, so it makes no difference which log you use. So let's see, I'm going to write log 3, 2x minus 1, is log 7, x plus 1. The whole point in doing that is to bring these things down to the front. Now, living in the treehouse grouped them together. So just know when you bring them down front that they're still grouped together. So it's x minus 1 in parentheses, log 3. And this is x plus 1 in parentheses, log 7. Well, this is the only thing that you have to remember. See, distributive property, we train ourselves, unfortunately, in the United States, because we read from left to right. We get so used to distributing from left to right that we forget that distribution can happen either direction. So this is really log 3 being multiplied by 2x minus 1. So you have to distribute it to both pieces. So I have to distribute log 3 to both of these. So it ends up being 2x log 3 minus 1 log 3. You don't really have to write the 1, but just so you know what I'm doing. Equals x log 7 plus 1 log 7. Now our goal here is just algebra. It's to solve for x. So in this case, I have x's on both sides of the equation, and you're going to do what you've always done in algebra. Get all your x's on one side. So I'm going to just move them to the left, because again, that's kind of what we usually do, which means I'm going to take this one to the other side. So I have 2x log 3 minus x log 7, because I just moved this one over. It was positive on the right-hand side, so it's going to be negative on the left. And I'm going to move everything that's not an x to the other side. So I have log 7 plus log 3. Is everybody okay with moving things around? Everybody understand what I'm doing? All right. Now, logarithms are a lot like radicals and a lot like variables. If they're not alike, you can't put them together. Log, even though log base, if they're both log base 10, the arguments are different. So log 7 and log 3 can't be put together. Well, they can be put together with multiplication. We're not going to do that in a second. But what I can do is factor out an x in order to get all my x's together. So that's what I'm going to do on the left-hand side. I'm going to look at this and go, okay, they have a GCF. Both of these have an x in common. So I'm going to factor out x. And if I remove an x from both of these, it would leave me 2 log 3 minus log 7 equals log 7 plus log 3. Good? And now I need to get x by itself. Divide by all that. 2 log 3 minus log 7. That is all you can do.
So you can't divide like the log 7 minus the log.
Because the fraction bar is a grouping symbol. So it's grouping all of that above it together and all that below it together. And so since they're not the same, you can't cancel anything. That is it. That's the exact answer. Now, if you want to find the decimal approximation, you plug it in your calculator. So log 7 plus log 3 over 2 log. And I get 12.11439. Are y'all okay? Sort of, guys? Okay. Does anybody have questions this far? Okay. All right, here's one of the harder ones.
Is it going to take up more space than that one? Because like this is what I got.
Yeah, it'll take up more space than that. Yes, you gotta factor it. So if you will, you can, for just a second, ignore the x's for just a minute and pretend that this is just e squared minus 8e plus 7. Could you factor that? Sure, how would you factor that?
E minus, or e plus 8, or e minus 1, what would that be?
E minus 8.
Wait a minute.
Seven
Looking for
and
the
one.
fact. 7 and 1.
Negative 1.
Negative 7, negative 1.
Oh,
All right, well now we can go back and put the x's on it. So that would be e to the x minus 7 and e to the x minus 1. Which means I actually have two separate equations here. I have ex minus 7 equals 0. And I have e to the x minus 1 equals 0. And I have to solve them both. So I'm going to move the 7 over. So that makes this e to the x equals 7. Can you make that into like bases?
No.
No. So we're going to use natural log because it's e. And I'm going to write natural log in front of both sides. So it's going to be natural log e to the x equals natural log 7. What happens to natural log e to the x?
Is it 1 to the x?
It's just x.
It's just x, right? So the answer to this one is just natural log 7. I have to solve this one the same way, so I'm going to write e to the x equals 1. Natural log e to the x equals natural log of 1. Do you remember what we learned about natural log of 1?
It's 0?
It's 0. So this one, x equals 0. Okay. Here's another one.
Oh no.
This is actually easier.
Oh. I thought you were gonna do like 4, 3, 2. I was like, oh gosh.
No, but look at this one. So what makes this one different? The last one had addition between the two, or subtraction. Very good. Multiplication, if you have bases, alike bases, when you multiply, you just add the exponents. So that means what I really have here is e to the 5x minus 1 equals 5e.
Or would you just do natural log?
Yep, now we're just going to do natural log on both sides. All of this gets to come down to the front. Now remember, it was living in a treehouse together, so it's all grouped together. 5x minus 1, natural log e, equals natural log 5e. Now, distribute this. 5x natural log e minus natural log e equals. Now, right here, I am going to split my argument up. How do you split up an argument that's being multiplied? Right. So I'm going to have natural log 5 plus natural log e. All right, now I need to get, oh, my x is already by itself. So I just need to move everything to the other side, if I can. So I have 5x.
Can we change natural log e to 1 or no?
Yeah. So 5x natural log e equals natural log 5 plus 1, because natural log of e is 1, plus 1, because that's 1 also.
Could we get rid of the natural log on the left side?
Yep. So this equals 5x equals natural log 5 plus 2 divided by 5. I'm not sure. I think it'll take it like that, but maybe you might have to put it in as natural log 5 of 5 plus 2/5. Do the same thing. And then you can plug it in your calculator to get the decimal approximation. Everybody good? All right. Let's do one more. This one's pretty easy, but just to remind you of something we may not remember.
Then we move on to another thing.
Yeah, we're going to solve in the reverse way.
Oh, okay.
All right. So can I rewrite 50 with a base of e? No. So I'm going to write natural log on both sides. So natural log e to the x equals natural log 50. That means my absolute value x gets to come to the front. Natural log e is 1, so it's gone. Equals natural log 50. Now, reminder about solving absolute values. Whenever you solve an absolute value, you actually split it into two equations, positive and negative. So it becomes x equals natural log 50 and x equals negative natural log 50. You cannot take a negative log, but you can have a log that's negative. Does that make sense? Your argument, what's inside the parentheses, can never be negative. But you can have a negative sign in front of the entire logarithm. So this ends up being your final answer. Everybody okay? Not too bad?
Is your answer?
Yeah, they're both your answers. Absolute values are have a positive, almost always have a positive or negative, unless the answer is 0.